Hi and welcome to the Softimage tire smoke tutorial. My name is Ola Madsen and I'll be your guide during the next hour or so. If we open an Explorer, we'll see that we have 4 grids positioned at the base of each wheel, and this is of course from where we want to emit the particles. So select a group and from the Particles Create menu choose Basic Emission. Let's begin with decreasing the rate to about 100 and change the shape to spheres, and increasing the speed to 100 as well, and press Alt 9 to open an ice tree. So the first couple of nodes that we'll add are essentially just randomized nodes, and this is of course to add a more natural variation to the cloud. And the first value to randomize is the size of the particles. So get the randomized value by range and connect it to the size input. Open the property page and set a minimum value to 2 and the maximum value to 4. The next attribute to randomize is the mass value, and the mass is a very important attribute of any simulation for that matter, because the mass determines how the particle will react to the forces which we'll add later on. So set the minimum value to 0.1 and the maximum value to 0.3. And then moving on is the orientation. And while you obviously can't see that at the moment because it's spheres, and spheres looks, well, exactly the same from all angles, we will be using volumetric shading later on to shade the particles, and if all the particles are oriented exactly the same, there's a great chance or great risk that we'll get patterns throughout the clouds, which really isn't something we want. So get a randomized rotation by cone and connect it to the orientation input of the emit from geometry. Open the property page and change the end angle to 360. We also want to randomize the direction which the particles are emitted in. Currently the particles are emitted in a straight line, and we do want to add a bit of variation to this. Not that much, but at least a little. And this is done with a node called Randomized Direction. So get one of those and connect it to the Execute on Emit 1 input of the emit from geometry. Open the property page and set the start angle to 10 and the end angle to 10. Sorry, the start angle to -10 and the end angle to +10, or well, just 10. Another important attribute of the particles is the particle age. Get the set particle age limit and connect it to the emit from geometry node. By default, all the particles will be assigned an age limit of exactly 4 seconds, and this of course needs to be randomized as well. So get another randomized value by range and connect it to the age limit, and set the minimum value to 2 seconds and the maximum value to 6. Let me just rearrange this a bit. So Once the particle have reached their age limit, they have played their part and is no longer needed in simulation. So to delete them, get a delete particle at age limit node and connect it to the execute of the simulation route. So if we play back the animation now, we can see that once the particle reach the end of their life, they're deleted and will no longer be part of the simulation. So next we need to add some forces. So get an add force node and a drag force and a wind force. Connect the add force to the forces input and the wind to the force input and the drag force to the add forces as well. Well, let me just disconnect that for a moment so you can see what the drag force actually does. The drag force is acting as air resistance. It essentially decreases the particle's velocity over time, so if there's no other forces added, the particle will essentially or eventually just stop moving altogether. The value is perhaps a bit high at the moment, so set it to about 0.025. So it doesn't have that drastic effect on the particle, but it will add some resistance to it. The wind force is well, it's acting as wind, and by changing the direction or the speed, you can make the particles fly off in any direction you want. Looking at the property page, it may appear that the wind can only have one direction, either in X, Y or Z. However, looking at the node itself, the node accepts input from other nodes, so we can add another randomized node here as well to make it scatter or to give it a more random direction. So get another randomized vector by cone this time, because we are working with vectors, and connect it to the wind direction. Open the property page and set the start angle to -35 and the end angle to 35. And we want the wind to flow or blow in the negative Z direction. In addition to randomizing the direction the wind is blowing, we can also randomize the speed of the wind. So get another randomized value by range and connect it to the speed input of the wind force. Set the minimum value to about 10 and the maximum value to 30. By adding these two randomized nodes to the wind force, we've essentially created sorts of turbulence that will scatter or expand the cloud in a sort of random fashion, which should turn out rather nice. So if we play back the animation, we can see that the particles are spreading, and it's not looking that uniform at all. Another force that can be useful to add if you want to create sort of light and fluffy cloud is the neighboring particle force. What this force does is it will either attract or repel the particles from one another based on their distance. So if we just move some of these property pages out of the way, so let me just increase the value so you can see what's going on. So if the particles are within 10 units from one another, they will attract, act sort of like magnets, and if we set the strength to a negative value, you'll get the opposite, where they are repelled from one another. So if you're going for a light and fluffy cloud, this is a good force to add. So let's return to the particle size and make some changes to it, so they'll gradually increase in size over their life. Let me just get rid of that node. So the node we're looking for is called Modify Particle Size. This node enables us to do a couple of things. We can either just set a new size for the particles, or we can set the size based on its age percentage. So if we want, we can have the particles start off really small or at the size of 0, and then gradually increase their size over its lifetime. You can then use the profile curve to define how the size will change over time. So the source parameter we want to change or want to use is the age percentage, and the modification type, since we already defined a random value earlier in the ice tree, we really don't want to set a completely new value, but rather using the initial size. And we want the initial size of the particles to be multiplied by 4 or 4 times over its lifetime. So it's when the particle, just as the particle dies, it will be 4 times as big as when it was born. We also need to change the profile curve, because the current profile will make the particle gradually, very slowly change in size, and that is not what we want. We want the particles to change very rapidly, so start off really small, just beneath the wheel, and grow in size as it passes beneath the car. So start by moving this value to about 0.1 or 0.15 or something like that, and change the slope handle to create an arc, and this will force the particle to rapidly grow in size, and then continue to grow throughout its life. So let's rewind the scene and see what we have so far. Okay, we might need to actually we might need to connect the node as well for for it to have an effect. So Let's try it again, and perhaps we need to lower this value a bit, move it back to 0 again. So yeah, I think that would be a bit better. So the next task is to create a sort of billowing effect, or make the particle spin. So the effect we want to create is for the particles to rotate away from the center as they're emitted. And to do this we need a couple of nodes. First we need a spin particle node, and if we connect this to the execute of the simulation node and open its property page, we can see that there are a couple of ways we can rotate or spin the particle, and there is an effect called tumble. It's not exactly what we're looking for, so let me bring up the ice tree again. So open the spin particle property page and change the axis to relative to input position. This enables us to use our own axis for rotating the particles, and for this we need two other nodes. We need to get the current point position, and we need to get the location where the particle was emitted. So get particle emit location, and we need an add node to add these two positions together. This will give us a vector or a 3D vector that we can then use to rotate the individual particles. So connect the result of the add node to the input position of the spin particle node. So I'm just gonna change a couple of settings so we can see what's going on. As you can see, all the particles are rotating outwards or away from the center of the cloud, which is exactly what we wanted. So the spin rate controls the spin rate or the speed of the rotation. Currently the particles are spinning at a constant rate throughout the life, and this is not quite the effect we want. Instead we want the particles to gradually spin less and less as it gets older and get closer to its age limit. To achieve this we can use a node called modulate value by age percentage. And what this node does is allow us to modulate or change just about any value based on the particle's age percentage, which in this case is the spin rate. So connect the value output to the spin rate input of the spin particle node and open the property page. Since we're connected to the spin rate input, it means that all the old values have been overridden by the values found in this property page instead. So to control the actual spin rate of the particle, we will use the base value, and the profile will define how much or how many percent of the base value the particle should spin over its lifetime. So this is where the particle is born, and this is at the end of the life. And the Curry profile says that when the particle is born, it should have 100% of the base value, and then gradually diminish down to 0%, or which is nothing when it reaches the end of the life. A spin value of 0.5 actually turned out to work rather nicely, so set it back to 0.5. However, when the particle reaches the end of its life, it should still have some spin value, so move it to about 0.5 or so. So let me just clean up the view a bit, and let's see what we have so far. Okay, maybe it's a bit difficult to see what's going on since there's so many particles, so let's just quickly lower the number of particles. And perhaps increase the speed a bit to separate the cloud a bit from the car. Yeah, that looks much better. Okay, let's set it back to about 100 and change the shape back to spheres. So we have one last thing to fix before moving on to the actual shading of the particles. If we play back the animation again, we can see that the cloud expands in all directions, including into the ground, and this is not really the effect we want. To fix this, we can use an object that will act as a stand-in for the ground and a node called flow around surface. So start by getting the flow around surface node, and connect it to the new execute one, and then we need to feed the object or the surface which the particles are to react to. So press A to open an explorer and drag and drop the ground flow surface and connect it to the surface 1 input. So let me just quickly unhide this object so you can see what it is. In this example it's just a big cube, but it would work equally well if you're using more complex geometry or terrain or anything like that. So let me just hide it again, and let's see what we have so far. So the final step is to add some control for the transparency and make the particles gradually fade out as they're getting closer to the end of their life. So this is done with a node called modify particle color. And while you can set the particle color with this node as well, we're going to control the colors from within the shader rather than the ice tree. So the only bit we're interested in is the alpha, or the transparency. And the source we want to use is of course the age percentage. So the value on the left corresponds to the birth of the particle. Obviously we don't want them to be completely opaque, so set this value to about 0.2 or so. 0.2, and the value on the right corresponds to the depth of the particle, and when the particle die we want the alpha or the transparency to be 0, so it's gradually just fades away. And close the property page and connect it to the simulation root, and let's play back the animation again, and you'll see that we gradually get the particles to fade out rather than just abruptly disappearing as they did before.